Well, good afternoon, everyone, and welcome along to this latest Fusion21 webinar, Building a Safer Future, a focus on cladding. Many of you will be wrestling with issues of what to do with the cladding that's on your existing buildings and how best to work through any issues you currently have. And again, this is a topic that a number of you members have asked if we would be able to run, and I'm delighted that we've got together two excellent speakers this afternoon. Before I sort of move on to introducing the speakers, what I'm going to do is that if you're unfamiliar with this webinar, if you haven't been on one of our webinars before, the orange button on the panel in front of you can minimizes the control panel. If you are having difficulties with the audio, you can adjust the audio settings by clicking on the audio button. Some people do tell us that if they are having problems logging in and logging back out again, can actually solve it. And then the final thing we want to do is we do want to encourage you to take part, and whilst you, the audience, are on mute, do please use the question box to answer any questions. We'll go through Q&A at the end of presentations, each individual presentation, and again at the end. If we don't get a chance to answer all your questions, then again the panelists have agreed that we'll circulate those questions afterwards and come back to you. But don't be shy. Do please feel free to answer a question. So without further ado, I'm delighted to introduce to you our panel, our speakers for this afternoon. So we have Gary Jackson, who's the director at Michael Dyson Associates, and to some extent a late replacement for Toby Blunston, who was on the invite list, but we're delighted that the managing director of Lawtech, David Lawrence, has been able to join us. And again, I think that most of you will enjoy this afternoon's presentation and setting. And so without further ado, I'm going to pass over to Gary, who is going to take you through his presentation. If I can just pass over the controls to him. So Gary, hopefully you've got the presentation there, and over to you.
Okay, I don't. Yes. Okay. Thank you. Good afternoon, everyone. Gary Jackson, Michael Dyson Associates. For those that don't know of us, we're a multidisciplinary organisation serving the social housing sector, and amongst the services we deliver is structural engineering and relating to high rise and so forth. This afternoon I've been asked to give an overview of things you might want to consider before engaging in a large-scale investment onto high-rise blocks. It's a massive subject, and 20 minutes isn't an awful long time to get through that. So what I've tried to do is encapsulate a list of things that you'll consider and take advice on, and hopefully make the right kinds of decisions when you're spending all that money. So first off, nothing's happening. Okay, what is high rise? It's an important distinction because there is some, I won't say dispute, but there are some differences in the way high rise are looked at. Since 1986, it tended to be anything over 5 stories because the BRE was gathering information post Ronan Point, and they used 4 stories and above as a demarcation. But the major repairs allowance parlance is blocks of 6 or more stories. The home quality mark by the BRE refers to anything over 18 metres, but crucially, the building regulations refer to anything over 5 stories, and that's specifically in relation to disproportionate collapse, which is something that does need consideration, and it's something that I'll be touching upon later. So in terms of what constitutes high rise, it's around about 5 stories. Then we had the tragedy at Grenfell, and suddenly there was a focus on an 18-metre mark, and all the mandates and the letters and the guidance focused on 6 stories and above. So we've got a little issue here that in terms of applying cladding and designing cladding and thinking about how it will perform, it's 6 stories and above, greater than 5 stories or 18 meters. But interestingly, when you're considering the structure upon which you're hanging this cladding, you need to consider the 5th story as well, because that's a demarcation as far as disproportionate collapse goes under building regulation A3. How many have we got? Well, I was struggling with this. I've looked at all sorts of sources, and the MHCLG currently publishes around about 12,500 high-rise residential blocks in the UK, of which 6,000 are social sector. There's no real definition on that. And reading on the subject, research by a chap called Michael Stratton says that around about 6,500 high-rise blocks were built post-1945 in the UK. But of course, there have been demolitions which have reduced that number. And current thinking, evidenced in various reports, is there's around about 4,000 high-rise residential in the social sector at the moment. So, why do you want to do it? Why would you want to reclad these blocks? Well, there's a general trend here, and it's primarily to improve thermal efficiency and resolve the damp issues which are generally associated with 1960s and 70s design and construction. There are also benefits in protecting the substrate. These things have got envelopes in their original form or in later forms that probably don't perform as well as they might do. And so your new cladding system might be seeking to protect that substrate. If you're already spending money on responsive or even cyclical maintenance of, say, pointing or large areas of these blocks, then it's very tempting to want to put a cladding system on to get a fix and forget solution for the next 25 years. There's also the aesthetics to consider. Obviously, don't to look better. A lot of these things in their original form are quite ropey and unattractive. There's also considerations of other big investments. Why not put cladding alongside that, such as re-windowing or re-balconing these blocks? And last but not least, certainly since Grenfell, there's the fire resilience issue associated primarily with asbestos-containing materials, high-pressure laminates, and the presence of cavities and absence of fire breaks on these blocks. So there are lots of good reasons to want to invest in these blocks by recladding them. Right, okay, general issues to consider. This is granny and eggs time. This is speaking as an engineer. This is more your remit than mine as housing managers and owners of these blocks. But first of all, are these blocks viable in the long term on a business proposition? You need to think about current demand and changes in demographics. Do we want an elderly population rammed up on the 15, 16 stories of these blocks? Also, a lot of these blocks require significant investment before you can actually work on them. So are they currently fit for purpose? And if not, what's that going to cost to deal with them? And they are quite expensive to own. You've got conventional responsive repairs and so forth, but they tend to come in big hits, you know, wholesale renewal of kitchens and bathrooms, wholesale renewal of lifts, heating, power plants and so forth. A lot of the blocks have concierge or security requirements. And also waste management. So they are quite expensive to own, and you need to balance that against the cost of doing something else. And something that's sort of prevalent in social housing is the presence of leaseholders within these blocks. I'm sure you're all aware of the Section 20 provisions, and these people should be contributing to the upkeep of these blocks, but quite often they end up being investment blockers because they don't want to spend any of their own money. So that's something else to consider in general terms. So here's some practical issues to consider. And I'll split them into primarily the structure, the fabric, and other considerations. And in terms of structure, you need to think about what type of structure is it that you've got in making up these blocks. You need to look at the fire safety restrictions. What can't you do in terms of compartmentalisation? How many stairwells have we got? What do you need to do to bring them to current standards? What work do you need to do to the structure and/or to the structure prior to putting the cladding on, and what limitations are there? What can the structure actually hold in terms of additional loading? For the fabric, I'm referring to a substrate, which is basically the envelope that's non-structural. It may well be a secondary structural component, such as a story height wall, but it's secondary to the primary frame. And we're looking there for fire resilience, and also longevity. You need to think about fenestration. You'll have lots of masons openings. How do you deal with those in terms of fire resilience, in terms of application, and in terms of detailing old to new materials? And then other considerations beyond that is, what do you actually know about these blocks? Do you know how they were designed and constructed? What contemporaneous records do you have? Do you have the as-built? Do you have the original drawings and calculations and so forth? Is there a cladding system in place now that requires removal? And what will happen when you take it off? Can you take it off all at once? Does it need to be taken off in bits? And what's the implications of taking off something that's been fixed there for the past 30 or 40 years? You may well have attached structures and fittings, particularly on the roof. And last but by no means least, in other considerations, you need access to do work to blocks. Do these blocks lend themselves to having mast climbers or scaffolding or other means of access readily available? And what provisions do you need to make, and how much will that cost before you can actually start sticking things onto the wall? Let's talk about structure. I've just used two general types, framed and shear wall or cross wall construction. Frame structures tend to be steel or concrete, and shear walls and cross walls tend to be concrete or concrete and another material. But quite frankly, in our experience, it's mostly concrete. And in frame structures, you have in situ concrete frames, and in shear wall or cross walls, they tend to be large panel systems or LPS. Frames are more resilient against disproportionate collapse because they offer alternative means of rerouting loads in the event of distress, and they're generally well tied together in any event. But they only offer limited primary fixing points for cladding systems, such as the slab ends and the faces of columns. Large panelled systems, they present issues relating to disproportionate collapse, and are put often requiring, again in our experience, they always require some kind of structural improvement. But they do offer broader fixing options for retrospective cladding, because by definition the envelope is structural. And those of you not familiar with what these things look like, I've chosen a wimpy no-fine style of construction, which is generally reinforced in situ concrete frame, and between the columns is no-fines concrete to create walls, primarily on the envelope and also the compartment walls inside. And the whole shebang is usually overlaid with no-fines concrete and rendered over. There are exceptions to that. We've seen no-fines blocks with brick outer skins, but in general terms, you can see a perimeter of a block supported by columns, and you've got columns within the footprint, which also provide the means by which walls are composed in no-fines concrete to create compartments. And the way these look on plan is there's a column, and typically the no-fines wall, that's the outside, that's the inside, the no-fines wall will spread across the face of the column, obscuring it. And then on top of this lot, there's typically a rendered finish. And looking sectionally, it looks like that, which is basically a solid no-fines concrete wall placed between reinforced in situ concrete columns, joined monolithically to the reinforced concrete slabs. So here's a picture of a no-fines block. This isn't no-fines concrete. This is the structural concrete, and this is the junction of a floor and a column. And you can see that the concrete is well compacted, and you can never tell the condition of concrete just by looking at it. But we can tell from this photograph that it's not been carbonated because it's got phenolphthalein on, which has turned purple, meaning that the concrete has not been affected by encroachment of carbonation. The result of that is fairly good order for the reinforcement that we've exposed. I've chosen a typical LPS block of reamer to show you these. These are referred to as gravity structures. It's basically self-weight that holds it together. There are fixings between panels, between walls to walls and walls to floors, but these are more associated with putting them together, bringing them onto site and dropping them from cranes and locating them. So there is some restraint offered by these fixing systems, but by and large, it's the gravity that holds them together. Therefore, there's a reliance on correct placement of the panels and what they call dry pot mortar, where they ram mortar beneath the panel feet to make it a tight joint with the floor. What does that look like? Well, I picked a nice easy one. It's a big square, and we've got what we call flank walls. These are the primary support walls, you'd normally refer to them as gables. And then across, hence the term cross walls, we've got concrete panels creating the walls between and obviously forming good solid compartments. On the reamers, we've also got walls running perpendicular to that, which spin from a central core, which sometimes is of in situ concrete, and on a reamer is generally in precast panels. Looking down onto a joint between panels, you can see hoops that join those together, and looking through a cross section at the same point, you can see there are hoops that come from the floor. We've got dowels that run along between a cutout joint and then the dowels that you see there. And in terms of what they look like, that's not particularly tidy, but it is an effective joint between two panels in a reamer block. I think at this point it's worthwhile talking about normal and accidental loading, because one of the key issues for large panel systems is disproportionate collapse. Normal loading is anything that's predictable. That's its self-weight, the use, that's the people, the furniture, the plant and so forth, wind loads, positive and negative, snow, and even retrospective cladding. Even though it's an eccentric load, it's still classed as normal because you designed for it. It's normal because you can understand what it's doing to the building and you can accommodate it. Accidental loading is referred to as overpressure due to explosion or impact, which relates back to the building regulations. What that basically means is an unforeseen explosion of a certain magnitude. Town gas can exert something like 34 kilonewtons per square metre, and bottled gas can exert 17 kilonewtons per metre square. So we have benchmarks for how much overpressure a block can withstand without being able to redirect loads, and they're established in manuals that have been drawn up by the BRE, and they're referable. So how do we deal with normal and accidental loading? Well, primarily through the original design. If you're looking at a block that was constructed in 1960, then it's been there 60 years. So by definition, it's coping with normal loading. You don't need an engineer for that. But if you're putting something new onto it, whether it's cladding or it's air source heat pumps or some mast installations for communications, you need to accept that as a normal load and accommodate that new load with some new provision. Accidental loading is something quite different because it's unforeseen other than in its magnitude. So you're concentrating on tying and redundancy. If a structure can demonstrably be seen to be tied together properly and there are alternative loads for path to be transferred in the event of a component failure, then you'll satisfy the requirements for accidental loading. And that's typically associated with framed structures. Unfortunately, with large panel systems, the panels are actually the source of the direction for loading. So if a panel goes, everything falls down and you get the progressive collapse that's associated with Ronan point. And that's very, very difficult to overcome. And so alongside introducing new measures such as tying and introducing columns and so forth to redirect loads, it's important to understand you can manage risk, the likelihood of occurrence. In the calculation for risk assessment, the outcome can be very, very severe. An explosion will be very severe in its outcome, its degree of harm. But if you can close the gap for the likelihood of occurrence by removing gas, by managing people taking gas bottled in there, removing people who've got medicinal gas and so forth, you are managing the risk and reducing the likelihood of occurrence. So there's a strategy that's structural and managerial associated with managing accidental loading. There's specific guidance on all this, and it's hundreds of pages thick, but there's a whole chapter on permissible deaths per thousand in the event of an explosion, which makes interesting reading. But unfortunately, there's no real guidance on managing the likelihoods, and the kinds of things that we've come across are hard concierge protocols, intelligent CCTV that will identify potential gas bottles and things like that and raise alarms and so forth. But other than that, you're pretty much in the hands of policing. What about fabric? Well, what's the condition of the fabric? Does it need stabilising, patch repairing? Do you need to retrospectively tie it back? Can you fix to or fix through? Can you fix through the fabric to a structural component, or do you need to fix to it And if that's the case, you need to think about a strategy for making sure that envelope can carry the weight you're putting on it. You'll have issues with mason's openings to do with cold bridging and future renewals. If you've got a lifespan of a cladding system that exceeds that of the windows, you want to make sure you've got provision for replacing the windows mid-life of the EWI. You'll have issues with rainwater management, not least if balconies are left exposed, you need to route the water somewhere. And also plain and simple rain washing down the outside of a block. If you've got absorptive materials, you'll end up with lots of staining and things like that. So think about things like that. Think about the detailing. You're putting something on that's going to be a various thickness onto the outside. If you've got a fairly rectangular scenario like the reamer block, happy days, not a problem. If you've got something that's H-shaped or fairly complex in footprint, then you've got a lot of issues to overcome in detailing a relatively thick material and making it work in terms of applying it, in terms of maintaining thermal movement differentials, and also for maintaining fire breaks. So choosing the correct system. Again, in my noddy way, I've just broke it into two different kinds. Rail systems, which go on rails, and direct fixed systems, which are stuck direct. Pretty simple, but essentially you get rail systems where the rail is fixed to the outside, and typically they're fixed to spanning systems, so they go to the ends of slabs, so you don't have too much to worry about the envelope, and they're generally referred to as rain screens or something like that. And the direct fixed system goes straight onto the outside of the envelope, an external wall insulation, EWI. And amongst all the other things you'll think about, the primary ones are satisfying building regs, fire resilience, the ability to fix it to what you're fixing it to, the thermal characteristics, how you're going to maintain and ultimately renew it, what does it look like, and also warranties and insurances. A warranty is probably only worth the paper it's written on. What you really need to look at is insurance-backed guarantees and third-party products that will allow you to go beyond the life of the company that installed the product. So that's a quick counter through the things to think about. So I think we can safely say that all systems will work, won't they? So what's the problem? Well, the real problem that we've found through experience is understanding the structural characteristics of the block that you're working with. If you don't understand them, then you won't fix the right product. You need to understand where you fix it on the structure to make sure it will stay there. And something that I haven't mentioned, but I've left till last, is workmanship, because we can design as much as we like, get that right, we can choose the right product. If it isn't put on properly, we'll have major problems. And workmanship has been an issue that the construction industry seems to struggle with. Going back to Ronan Point, when the Griffiths report famously said there were no workmanship issues at Ronan Point, about 14 years later, when they started demolishing it, the architect involved got a book out of it, cataloguing all the defects that were found as they dismantled the block. So there were lots of workmanship issues at Ronan Point. Grenfell were aware of, and even today, you know, as recently as this year, we're experiencing major issues with workmanship. You'll recall this slide from earlier showing you this lovely concrete and this lovely reinforcement. On the same block, on the same floor, 3 or 4 columns along, this column here has got the bottom missing because it's not been vibrated properly, the concrete hasn't dropped to the bottom, it's left the reinforcement exposed, and all you've got protecting that reinforcement is no fines concrete. Also, this concrete has got this reinforcement has got nothing supporting it in compression, so that's not really adequate in terms of as a resistance to downward forces. On the reamers, I showed you this rather attractive man-made joint here. Again, same block, we've got the hoop and we've got the dowel, and they're around about 50 millimeters apart. And it's not just on reamers. We've got scarm properties where there are hoops with no dowels. There are no hoops and no dowels. We've got camas properties where obviously someone thought about it and decided not to follow through. And we've got my favourite. This is another reamer block. And somebody decided they couldn't get the two lugs to work together, so they've used a fork to try and wrap it around the two lugs coming into the joint. At Grenfell, we're painfully aware of the workmanship issues there. It's widely publicised, so no need to dwell on that. But here's something interesting. This is from something that we've done within the last 12 months on one of our sites. where we notified the contractor that we were going to locate and test around about 70 fixings for pull tests, and we witnessed the installation and we witnessed the pull testing. And bear in mind that the contractor had fair warning of which fixings we were looking at. We had a 78% pass rate, which is a 22% failure rate. So that's in the knowledge that Michael Dyson Associates are going to be looking at these. We had a massive failure. So you've got to ask yourself what was going through their heads when they did that. And what it has done is it's led us to the conclusion that we're going to have to do extra monitoring during the installation. So rather than just leaving them alone to get on with it, we're going to be policing this job very closely. So I'd like to close, hopefully approaching 20 minutes, with a to-do list. And the to-do list is this. First of all, substantiate your business case. Very important, verify the structure and the fabric of the blocks you're looking at and test its structural capacity. We then recommend you test its resilience in fire. That's the substrate and the new cladding. And we recommend the involvement of a fire engineer, which will probably become mandatory in any event. You need to look at the installation process and say, can it be done? It's okay drawing something up on a tech sheet and saying your spacings are this, but when you're looking at 60-year-old concrete and 60-year-old bricks and things like that, make sure you understand the difficulties that the people on site will experience and combat that at source. And therefore, choose a system that's consistent with contiguous components, and by that I mean recognition that they will touch each other and that is sympathetic to long-term maintenance. We also recommend on your to-do list, get involved with the manufacturers of the system early doors, and also the people who do the fixings, because they're not always the same. And so make sure that the people who manufacture and possibly install the system are talking to the people who provide the fixings. Look at the wind loads. There's a lot of lip service paid to wind loads. It's there for a purpose, it's done for a purpose, and it's to actually modify your fixing patterns. So understand that and make sure you carry those out. And then two more big ones. Test the fixing system before you commence in earnest. So pick samples as we did and test them in situ and make sure that A, they're the right fixings for the job, and B, that the operatives know what they're doing on site. And then when you're on site doing the works, test the fixings throughout the construction period. Likewise, check interfaces throughout, seals, areas of thermal movement and so forth. And last but by no means least on this to-do list, follow the maintenance regime. If you've got a product that's got a BBA or other warranty for 25 years, the small print might say you need to go back in year 12 and change the seals, you need to go back in year 12 and change the grommets, da-de-da. If you fail to do that, you'll void the warranty. So make sure you understand your obligation as the purchaser of this system. And I got a bit carried away now. I've also done you a to not do list. This is what we think you shouldn't be doing. Do not assume anything is standard. Even if you've got as-built drawings, check it out. Don't assume a secondary structure such as a brick envelope or no fines concrete is any good for fixing. It might be, but don't assume. Check it. Never assume good workmanship in construction. And just as an aside, so we come across this a lot, and it wasn't really in the remit, but I've stuck it in. Never assume a roof can support more than its own mass. That's a big mistake. And finally, with respect, don't initiate investment without knowledge.
Excellent.
And that's it. Thank you.
Thanks very much, Gary, for that. Just got sort of one, well, two sort of quick comment. The one's really a statement, and I think you've actually just covered that, but which is around it's necessary to check construction on site and not rely on design drawings, as buildings are not always built as they were supposed to. And again, I assume that you will endorse that. Make sure you have a good look
Absolutely.
Before going too far.
The manufacturers publish test tables for sampling rates, and the BRE, theirs goes back, I think, to about 1987. It's an old one, but it's very good, and it's got a tiered approach. So on smaller jobs, I think it's geared for, but the first 20 are done at like 10%, the next 20 are done at 5%, and so forth. We'd recommend doubling that and really making it, you know, a front end curve, because what you're trying to do is you're not only testing the fixing, you're making it clear that people installing these things are going to be watched and they're going to be policed. And so if you hit them out at the beginning, they'll learn the lessons at the beginning, hopefully not repeat them.
Okay, that's excellent. Okay, well, brilliant. Well, keep your questions coming in. And as I said, I'm now going to hand over to somebody who is responsible for the fixing. So yeah, delighted that David Lawrence, Managing Director of Lawtech, is able to join us. Lawtech, one of our, along with Michael Dyson Associates, one of our valued suppliers on the Fusion21 framework. So yeah, it'd be interesting to hear some of the practical and again some of the schemes that you're working on, David. So over to you. Hopefully you should be able to access the slides, and yeah, there you go.
There we go, lovely. Okay. Yeah, afternoon. Sorry, I just need to get this under control. My name's David Lawrence. I'm the Managing Director of Lawtech Group, and I just need to go back to the beginning just quickly. Sorry, it's very sensitive. There we go. I'm going to use the click. So, yes, I'm the Managing Director of Lawtech Group, and also for my sins, I chair a business called SWIGA, which is the Solid Wall Insulation Guarantee Agency. It's a not-for-profit warranty provider, third-party warranty provider for external wall insulation systems. That's governed by industry, and it provides 25 and 10-year guarantees for external wall insulation. But just to give you a bit of a background, and we're going to throw through this quite quickly. It's going to be quite punchy. So just a quick background, we're a specialist envelope business, but we are a principal contractor. We don't work as a subcontractor, but we predominantly do envelope works with added items on, specialising in high-rise and fire safety and general repairs and maintenance. We have our own in-house design team that specialise in designing the cladding systems that we provide, and we have our own installers as well as labour-only installers, which I'll come to a bit later on to give you an insight of how the market works, which is ultimately what my remit was for, to give you the current situation and warts and all kind of thing, and where we are going forward and where we see the industry moving forward too. So to give you some idea of some projects, to give you a bit of background before we jump into the main meat of the sandwich, this is current site, which is removal of some ACM cladding and replacement. It's about just over £7 million. It's one of the buildings that was put up pre-Olympics, and it's, as you can see, a pretty extensive site, extensive work going on with the removal and replacement of the cladding, and also at the same time there are some structural elements to be carried out, and balcony decking, which was timber balcony decking, to be replaced. The building was built circa 2008, 2007, to give you an idea of the building timeline. And this is again the other end of the scale, really a small project for us. It went through Fusion21, this one, that's why I picked it really. And again, this is a removal of rain screen, cladding and reinstatement on a like-for-like basis. Just to give you an idea, both of them are rain screen, but we do dominate, or do a fair bit of external wall insulation as well, but we'll come to that in a bit more detail. So I just want to tell you really what the market is and how it is for a contractor. So the supply chain is divided really in that we have, on the rain screen side, we have fabricators, manufacturers and distribution. So rain screen cladding is what I would class as a kind of pick and mix sweetie situation. So you would normally purchase the actual cladding panels, so the actual an ACM, let's say a fire rated ACM or terracotta or other panel systems. You'd buy the panel from the panel manufacturer. That comes into the UK and it gets cut in the UK and it gets distributed. You would buy the framing system from a completely separate supplier. The systems tend not to be together. You would buy the fixings from a fixing supplier. You would buy the insulation from an insulation supplier. So on the rain screen market, which is where we see its weakness, is that you'd probably deal with between 3 and 6 suppliers to provide a rain screen system. External wall insulation, on the other hand, is system driven. It's system designers. You supply, you have one supplier and one supplier only. The fixings and all the finishes and the insulation, the fact that they may not be made by the system designer, they are purchased through that and controlled through that. So as you can imagine, there's a lot more control in product, which I've come to a little bit later on in this slide. Deliveries mainly are into the UK currently, very little made in the UK itself, unfortunately, other than dominated by the insulation. Non-combustible insulation is made in the UK quite heavily. And in terms of the reality of life of labour, there is probably a relatively small core of direct labour within businesses such as ours, and the majority is labour-only operatives employed by labour-only gangs that dominate and provide good service, but they're trained through businesses like us, and they're employed on a job-to-job basis through us. So the issue we have at the moment currently with distribution and quality control is there is a fair lack of knowledge with distributors in terms of product and quality control in our opinion. We often order products and we get delivered slight alternatives that look the same, and we have to be on our toes with regards to how we quality control product coming to site. And a very good example recently in the Grenfell inquiry was the discussion around the Kingspan and Celotex, and the fact that two insulation boards may look the same, but they are not the same, but they ended up on the same building. And that's something that we have to protect against even to this day. So, and in fact, I dealt with an issue yesterday on a site where we ordered something and something else turned up. So we expect distribution to be better, and we're working with them on that. It's fairly difficult to deal with. There is no barcode system. We prefer a barcode system in the market where we can have guarantees that we barcode products in and out, but that's something that the industry hasn't gone towards yet, unfortunately. So I've actually put a slide, and I didn't know that Dysons were going on about that, about understanding your building, and absolutely crucial when it comes to cladding in the current market. We've investigated more than 100 blocks of flats so far post Grenfell, and it's really important that you strategically look at the building, where you're going to open up, to look for the telltale signs. 99 times out of 100 you will not look in the middle of a wall in the middle of the building, because that's probably going to be the bit that's correct. It's looking at the junctions, at the detailing, at the fire breaks, how the wall is built up throughout, and go back as far as you can. This isn't a case of just looking at the cladding on the outside and then thinking you just need to replace that. This is about going back further, understanding how the block was built and what was expected. I would say that it's really important to work with a team alongside people like ourselves. It's better that way for us, is that we cannot be experts in everything, and there are going to be occasions where you need the fire consultants to provide the fire advice in certain situations, or engineers in certain other situations. You know, we can provide a substantial part of that advice, but for us, I think the blame game has to stop, and we prefer projects to move forward in terms of a holistic fashion, that there are several parties taking responsibility for the project, and no one kind of person has to take the blame, but everyone should also be trying to get to the correct solution. Just to give you an idea, we've out of the 100, it's more than 100, I think about 134 or something to date, but we have approximately a 90% failure rate. It's probably more than that, but I put that as a round number. And when I mean by a failure rate, this isn't just purely a case of whether the products on the building are combustible or not, albeit that is a relatively contentious issue with Grenfell and what the regs stated and what they didn't state and how complicated they were. However, we have found a multitude of issues. I totally agree with what Gary said earlier. The as-built drawings tend to be accurate in less than half of the situation that we find. Product substitution is quite prominent on these buildings, where on the drawings they say one product and a similar product's been fitted. We've had situations where the building was built 2 stories higher than it should have been. To give you some of the idea, Biggest issues around the fire breaks, predominantly fire break locations, lack of fire breaks in the wrong location, none around the windows, none around penetrations. That is a pretty regular occurrence. And ultimately, we're looking, and most clients are now looking to this EWS1 form that's out there, which came out last year. And we've seen some development and changes of attitude as that form's people have got used to that form, and I'll pick that a little bit further later up where I see that going. So yeah, EWS1 form and the building regulations, we kind of see the EWS1 form as the kingmaker, to be honest. What the insurers and mortgage companies decide is their requirement for valuing the property correctly and to be comfortable to insure it for fire and to insure the building is potentially slightly different to the regulations, may or may not be. And this form has come in and certainly shaken the market in terms of what people are willing to accept on buildings and what they're not. And pre this form, I would say that we were asked to look at removal of cladding predominantly, and there are certainly more things being looked at in terms of combustibility that you know, are looking to be removed. And it may well be, it may well be that the future changes on that. And the current concentration, of course, is above 18 metres. And again, further on, I do say where we think the market's going in the 18 metre scenario. And clearly, there's a statement about Euro Class A1 and A2, and that has issued a little bit of confusion in the marketplace. A1 and A2 are non-combustible. They are pretty much the same. There is a lot of politics around A1 being better than A2. We don't see that as the case in our business at all. And certainly an A1 product can be a metal, for example. An aluminium is a metal, which is A1, which melts at 300 degrees. But a product, for example, rock panel, which is a cladding system, is an A2 product, and that combusts at 1,200 degrees. So in that sense, in terms of fire, 300 degrees melting to 1,200 degrees combustible is maybe the wrong way around. So just be careful on how you consider A1 and A2. A lot of clients do say it's A1 must be better than A2. That's not necessarily the case. And so you have to understand how the Euro class works. There are some panels on the market currently that are solid aluminium A1 panels. We're still not quite comfortable how they achieve that rating, and that's all to do with the coating on top. So again, we still see some issues around certification and being aware of how in-depth you look at those certifications. Obviously, the A1 and A2 comes with its exclusions, which is membranes, windows, gaskets, sealants, and there is lists quite clearly on government websites now. That does have its issues. You can get an A1 vapor check layer these days. So again, that's something that you can look at enhancing the systems, even though it's on the exclusion list. But then we have the issues around laminated glass steel, which maybe shouldn't be on there. And then there's a lot of talk about the BS 8414 test, which then complies to BR 135. And the 8414 test, you have to understand how the test operates, and insurers aren't necessarily comfortable with the test. And an 8414 test is a fire test on a piece of wall, ultimately, I guess is the best way to describe it. The test doesn't require currently to have windows or any penetrations through, so hence the confusion, in our opinion anyway, with reference to fire breaks around windows, etc. An 8414 test is a test of a system on a wall. So how much is insurers are arguing that that test isn't necessarily real life, because no building has no windows and no penetration. So currently at the moment, obviously the regs are dominated by A1 and A2 non-combustible products, and again, whether that comes back into play or not, the 8414 test, but currently it's maybe a test that may change in the future. So where are we in terms of recladding? Well, the government launched two funds, many of you may know. The ACM fund is about 400 million, and the Building Safety Fund following that for non-ACM combustible products was 1 billion. The ACM fund is closed, and they are still processing some of the applications, and there are complications with how that is working. And the building safety fund is also closed, and it's being processed. There were around 2,800 applications, as we understand, for the building safety fund for buildings above 18 metres, so it gives you some idea of the demand for that works. Currently MHCLG are working with Faithful and Gould, and my dealings with those is they are working extremely hard and well from what I see to process the information that they are receiving. They've received a lot of information. They have a lot of staff working on this and processing this as fast as they can, but it's a lot that they need to deal with. But to give you an idea that we've been involved with an MHCLG since March when the lockdown occurred, because one of the government targets was to maintain this work on site. They felt that the removal of the cladding and its replacement was a priority, and so there's been regular engagement calls with contractors on a weekly, fortnightly basis to ensure that we put in place safety and to assist us to make sure that our sites remain open at all times, even during the height of the lockdown. So they've been very helpful on that to try and keep this work moving forward. And we then come to the big elephant in the room, which Gary mentioned, which is managing quality. And this industry needs a well, it's already received the wake-up call, but it fundamentally needs to change the way it quality controls itself. And that boils down to the contractor, in my opinion, people like us, the way that we set ourselves about. We can all tick a box on a PQQ and say that we have fantastic quality regimes, but actually what's on site is possibly a different methodology, and it's driven from the very top down, from people like me down, how we want to quality control our works. So to give you an idea of how complex it can be, and this is a process that we use currently, and it's been developed over the years, and it keeps on being developed. But I just want to show you really what you should expect as clients, what you should be demanding as clients on the quality of these buildings, because if you don't, we are going to be back here again and again and again. So this is making sure you start it right and you keep it very simple. The quality control needs to be simple. Why does it need to be simple? Because the guys doing the quality control are the men on site, and the men on site do not have fancy computers, fancy iPads. They do not walk around the scaffolding with A1 drawings in their hands because they're too big. So it needs to be developed for the men, not for the guys that are just going to audit the quality. Quality starts with the guys doing the works, training and actually making sure that they know what they are doing. We need to make the quality control available on the scaffolding. This isn't let's quality control, walk down 20 flights and then tick a box in the office, because by the time you get to there, then it's not going to work and you'd have forgotten half the stuff that you should have been noting down. Make it auditable, select your stages, very important, and track the progress. So we're then going to run into the detail slightly a bit more. So internally, I mentioned products. We product code everything. We product code internally because the industry does not provide us that. We product code because it ensures that our materials are ordered correctly and then they are checked when they come to site, which is how we can pick up small changes. So that is really important, that we need to make sure that we are getting the right product from the right manufacturer or the distributor. So we can see here we have a product which is Novia 1000, which is a vapor check layer, and it's from a distributor called Minster. You can buy it from other people, but we select, during our business, we select who we are going to get it from so that we know that we are going to receive that correct product. Secondly, once we've done that, we actually then photograph and we use graphical representation for the product, because it will turn up and it will be the wrong product and we need to protect against that. So we have posters around the site. We have the coding in the stores. When it gets unloaded, it gets checked against the posters, because that's something that the men on site can understand. And that's again putting it at their level, and it's making sure that what we have delivered turns up. And this is something that we then make available to our clients to make sure they have the ability to check what products have turned up, and when they're on the scaffolding that they don't see something that someone's got out of the boot of their car and wasn't meant to be on site. So that's really important, getting the products right. We then provide a grid system to our clients. We provide a grid system which then breaks down the quality control, how we're going to quality control it. We have that, this currently has changed recently. Because of the EWS1 form, we now grid it out per flat. As a result, we are able to provide the quality assurance packs per flat, which now leaseholders are using when they sell their property, so that they actually have a fully documented photographed control of what has occurred outside their flat. So the grid system is put in place on the scaffold list against the flats. And what you see there, the photographic representation on that slide, is actually laminated in A4, and those are blue tacked around the windows of the property and tied to the scaffolding, so that we know exactly where and when we are. So we can see that an example on that drawing is that we're on elevation EE, the floor height, and we're next to window number 1 on the grid reference, and that's how we're going to quality control the works. We then make all the drawings accessible on site, so we have A4 laminates of the drawings at various scaffold levels around the site and on show the crucial details. Again, this goes back to the point that how often do you see a man on site with an A1 drawing, clambering up the scaffolding, showing the detail, working out what it is he's meant to be installing? Very rarely, if not at all. And therefore, can you guarantee that he remembers that detail? He knows what he's got to do. If it changes, that then gets updated by our quality staff on site. We have dedicated quality control people that actually administer the drawings and administer the process on the scaffold itself to make sure that everything is visible and direct. And then we then grid everything out and we track it all. So this is a tracker, a tracker on a previous project where that gets administered, and we then know how each stage is recorded. And you can see that each one of these, I appreciate it's pretty small, but each one of these is a stage that we sign off. So you can see this is the number of stages that we provide in order that we can remove and reinstall cladding safely. So this is the number of checks you need to be looking at. And at the end, I appreciate that this end part of the building will look nice, but it's everything prior to that that you will not see. That is what we're seeing an issue with currently, that the items underneath aren't necessarily what they're meant to be. So it's really important that quality regime is brought into play. And again, it's important that we make sure that we have a visual identification on the scaffolding. We actually use color cards. So stage 1 is normally a white color card for us, and it gives you a breakdown of what we're going to quality control. And we have then stickers that we can put on work in progress or completed or do not proceed. And then we remove that card and we change it with a different color card. Again, this is getting it down to the guys and who sometimes their English isn't their first language. And they know that we've moved from the white stage to the blue stage, from the blue stage to the green stage, from the green, and so on. And then they know what section that they're working on. And we've also now implemented that each individual has an ID badge on site with the color of the ID badge, which then recognizes the stages of the systems that they're allowed to install on our behalf. Also, I'd just like to point out that it's important third-party accreditations. Some are much more important than others. We know that we have to jump through the hoops for ISO 9000 and 14000. I know as chairman of SWIGA how many hoops we have to jump through to be an installer for that, and there are different hoops for different systems and different high-rise, low-rise. But there are also some on there, and I'm more than happy to name it the Centre for Window and Cladding Technology. To be a member of that is you need to fill in an application form and pay them your fee. So I want to make people aware that some accreditations are worth it and some are much easier to obtain. So, please find out for yourselves what people have to do to become members of organisations. It's important because we can all put stickers on the bottom of our letterhead, but it's important that you understand what they mean. Going forward, going forward, where are we and where are we going forward as a contractor? there's a lot of problems out there at the moment which need resolving. It's going to take a long time. So insurances, PI is a complete nightmare at the moment. It's a fairly bare market. Many of the reinsurers have left the Lloyd's market. I deal personally with the Lloyd's market and our brokers directly, and probably about 70% of the PI insurers have decided to walk away from the market. And in fact, an insurer, a very large reinsurer, stated to myself that they'd rather insure an oil rig than they would a cladding business right now. So PI is going up significantly in price. All PIs have endorsements on them now for combustible cladding. So as much as you may want it, we on our one, for example, and it's a standard clause that's going to come across the industry, is we are no longer allowed to put combustible products on the buildings. We don't anyway, but just to make you aware, that endorsement is on the policies now. And in addition, you can no longer get PI insurance for any one claim as a cladding contractor. That has completely removed from the market. So now the claims are in the aggregate. So when you are letting contracts out or tendering, no one's probably going to tell you until it's too late, but the any one claim situation on PI has just disappeared from the market. And then we then come to performance bonds, and that hasn't been affected by Grenfell so much, but COVID-19 has massively affected the bond market. Performance bonds, a lot of businesses are running scared. So again, there is significantly less market availability to obtaining bonds. Bond prices as a result are going up. So just be aware of that. Secondly, because of the Building Safety Fund and the ACM fund and the way that it's being operated, there is suddenly a massive increase in the number of tenders that are coming out with regards to cladding, and we are probably receiving 2 or 3 per week of a very high in terms of value of size. And there is only so much that we can physically price, and there's only so much that we can physically do. So being, how is that going to affect the future? Well, it's going to affect the future as I put further down the slide, supply and demand. We can see 2021 being so busy that I think that it's inevitable that there are going to be issues, because we are accelerating in terms of the volume that needs to be done, and you need to be aware of that is the case. Again, that's affecting, we've already seen it now affecting access contractors and scaffolders, because high rise, we tend to use NASC members only because that's what we're comfortable with as a business. But again, access contractors are becoming very busy. Again, that may put a demand on the price. And then we have the Brexit issue. Suppliers are reporting that potentially it's an additional 4-week delay on products is what they're predicting. But operatives is an issue for Brexit. If you are a cladding operative, you do not score enough points after 1st of January 2021 to be able to come into this country and work. You do not score enough of the points on the immigration. It's something that we brought up with MHCLG, but currently come the 1st of January, the number of operatives in the UK will remain. And then I appreciate it's a good thing training people, but ultimately we would then need to increase resources by training. The issue with that is how long does it take to train an individual operative for cladding? In my opinion, it's probably about 2 to 3 years before they become any good. And we're talking about introductory courses taking about 3 months, then they turn into apprenticeships. So it does take time to get competent installers. And then we come to the competent installers and specialist contractors, and I would say that there aren't many of us around that are at the level that there should be, and certainly what we've seen in workmanship is that borne true. Again, the knowledge is quite restricted in this industry. Fire engineers are in demand so much, and chartered surveyors to fill in the EWS1 form are very rare and 10 to a penny. So again, it all leads down to a supply and demand situation that we can see coming forward. And the government deadlines that are being provided, we see them as being very short. We see the amount of cladding out there that may or may not have to be removed as being a potential 5 to 10 year regime. not a 18-month regime. So again, learning the lessons that we had in the past, especially with regards to the government schemes around sustainability, the likes of CESP, which led to ECO and Green Deal. To give you an idea, on the external wall insulation side, on that pre-Green Deal and ECO, there are about 50 to 60 businesses in the UK that installed it. And within the space of 12 months, there were 800 companies registered on the Green Deal website that could install it. And I would probably pertain that that's not necessarily possible to have that and maintain good standards. So again, that's something that we would like to just reiterate. It's I always say it's like a goose laying a golden egg, but the golden egg's so big that you drop it and it smashes on the floor, and we just need to be very careful that it's of a relevant size and time, that we all can make sure that we do this work. And let's be honest, we do it for a second time, not for a third time, and that's very important to us as an industry. We need to get the cladding industry's name back to where it should be. And so where do we see the future? Well, we see the future for cladding companies, and we're talking Rainstream specifically, to be more system driven. We think that's important because at the moment we can buy our parts from elsewhere, and we can get Chinese fixings, for example, on fixings if we wish to. Training and long-term opportunities for businesses like us, and not to have start-stop. Previously, government was start-stop, start-stop, and for us, businesses, we need to invest, and we'd like to have a little bit more long-term opportunities, and with clients like yourselves. The Green Deal and sustainable agendas coming through, and a lot of people are talking about that as a way out of COVID. So again, that might put a bit more pressure on supply chains. And changing procurement methods. I think one thing that Grenfell potentially has taught us is that design and build may be slightly, maybe a thing of the past, and having a lot of the work that we're carrying out is two-stage pre-construction service agreements. So working with us, working with the likes of Dyson's with us to design a system, to trust contractors to design the right system with consultants to lead to a more open method of working. Understand that you're the client. You're the client. If you would like a particular product, then demand a product, and don't use the value engineering classic. Value engineering ultimately is saving money and maybe trying to make a price that was tendered that was too low viable. So again, you pay for what you get, and as value for money is key here. And if you pay too little for something, then you may have bought something that is not capable of doing what you thought it was going to do. And if you pay a little bit more money, maybe that's the option. I think people need to understand that that's where the market has to go, and contractors, unfortunately, dare I say, but contractors need to make a profit, and sometimes I think that needs to be thought about. And again, longer term agreements, I think that's important. We're certainly in discussions with various suppliers, clients about longer term, because there is going to be a significant squeeze on supply chain, and that's really important. To give you where this is going, I can see us running out of good operatives very quickly in 2021 to be able to rectify this work. And I think that's me. So hopefully it gives you an insight in where I see it, where we think it's going, and to reiterate what Gary said, quality control, and the other really important thing is quality control.
Yeah. Thanks very much, David. That was really fascinating. I don't know whether to go and lie down and woe is nigh, and the horses riding over the apocalypse and riding over the edge. But anyway, sticking with organisations such as Michael Dyson Associates, Lawtech, and procured through Fusion21 may well be will hopefully be the answer. But clearly there are some significant challenges out there. There are a couple of questions. I'm conscious of time, but there are a couple of questions that I do want to go through. And one is just picking up from what you sort of said before. So there's the question around sort of failure rate, and again, so questions for sort of both of you in terms of looking at it. You mentioned 90% failure rate. Is that because you've been looking at the high risk buildings first, or actually is there a view that when you look at the less risky buildings, it is just a sense of we are in a mess because of, again, some of the things both of you articulated around general building standards of the past. David, do you want to sort of?
Yeah, I'll go. Yes, I think it's sensible to look at the more risky buildings first, and yes, that's probably about 80% of the investigations we've carried out above 18 metres. Do I see this as a problem below 11 metres, and do I think the building regs will go below 11 metres? Go between above 11. Do I think that? Yes, I probably think that we're going to see a change in the regulations to 11 metres and above. If I was a betting man, but that's for the government to make that decision. And in terms of what we're seeing, ultimately it boils down to workmanship. There is a little bit of confusion, and there has been, which I think is probably cleared up now with building regulations and what can and can't be installed, and that is changing. And there are systems that are 8414 tested that have combustible insulation within them. So, technically they would have passed, but now, if you were to do it now, they wouldn't. So, but for me, predominantly it's workmanship, and it's all around the detailing is what we're seeing. We don't see, we just see a consistent workmanship issue ultimately in terms of that.
Yeah. Gary, your observation?
Yeah, I mean, going forward, we need, as we're talking about, David's mentioning the quality processes that are put in place from here on in, but we are still dealing with a legacy that goes back to the early 1960s. And if we forget the past, we're doomed to repeat it. A lot of the issues that we identify are what we would call Friday-itis, people being paid on piecework, having to carry fixings up many flights of scaffolding, install them or not, depending on whether they want to go to the pub or not. And we've got photographs of bolts discarded or plates just lying around when they should have been fit to put panels together. And that's a function not only of a lack of management, but the fact that these people were paid on piecework, and they could come down and say, I put 50 bolts in today, boss. There's no one to evidence that. And we need to look at the way people are remunerated now, and the way that they are managed on site, and the confidence that we can put into the installers to make sure they don't do that and move away from that. And taking that upper level is the way that contractors and the installation companies are managed in terms of commercial arrangements as well as the design constraints.
Yeah. Okay. There's a question here on. Well, I'll read it out. The insurance market does not look favourably upon consultants signing EWS1 forms, as this potentially exposes the insured and the insurance company to potential claims. Is that? Yeah. Well, the question is, would welcome the panel's comments. So again, David, do you want to go first?
Yeah, I suppose it's an area, got to be careful what I say, but yeah, the EWS1 form, obviously designed by Barclays and the RICS, and it was aimed to help get the housing market moving in flats. And what it's done is it's made consultants extremely nervous signing a form with their PI insurance ultimately, and that has then led to further issues. And I suppose the situation is that if you were to say, let's investigate a building, and you find everything is to your satisfaction, but the reality of life is you've only had a look at about 0.01% of that building, and you couldn't never guarantee that the rest of it's fantastic. But so the only way you can ever guarantee an EWS1 form is to remove it and do it under controlled conditions and go, that's fantastic, I know exactly what's there. So that's the issue, and it's going to be pretty difficult to resolve. Ultimately, at the moment, the EWS1 forms that we're seeing, as long as they're, most of them are all caveated with something, and making sure that caveat is correct and present and good enough for insurers and mortgage companies, and it's a difficult area to resolve. That's all I see. It's very difficult, and it's forever changing.
Gary, any quick thoughts?
Yeah, it's in danger of becoming a risk dumping exercise, and really, it shouldn't be about just dumping the risk. It should be about making sure things are right. And you're right, David. These things are caveated. We'll do that ourselves. But the bottom line is, until you actually expose 100% of an envelope, you're not going to know. So you've got to caveat with a due of reasonableness and in the interest of due diligence. and as long as everyone's satisfied with that, I think it's a work in progress and it does need further development.
Okay, I'm going to ask a couple more questions, so hopefully audience you'll bear with us until, let's say, 1:15. So next question is regarding EWI systems, where these systems contain combustible insulation, will this need to be replaced with A1 or A2 class insulation, or will EWI with combustible insulation likely to achieve BR135 classification? Again, I don't know who wants to go first. Gary, is that one for you, or I'm just chucking these grenades?
Yeah, that's me. This is a relatively, again, a complex area. So yeah, so there are systems with combustible cladding that have in the past been tested to BR135 and are certified, and in the past that would have been a system that people would have put forward to be acceptable on a high-rise building. Being very careful what I say here. What's come out of post-Grenfell and the regulation changes at the moment are that if it's got insulation that is combustible, currently it is stating that that is no longer something that would be applicable on a building as we understand it. It's quite a moving feast. And again, going back to the EWS1 form, that's going to be a tricky one, because would the insurers and mortgage companies be comfortable with that is another area. So it's an area I'd probably say to seek further advice from my peers and experts more than myself. The one advantage with external wall insulation is it doesn't have a cavity if it's directly fixed, so we have that issue removed, and it is different, and there have been fires on high rises with external wall insulation and it's performed very well. And I know of fires on EWI blocks where the insulant is EPS and it's performed very well and it hasn't spread. So at the moment it's all around the nervousness, and from a political perspective, I guess the residents in that property might feel more nervous, the fact that it was a combustible insulant. So it's an area I'd probably suggest you seek further advice from experts, and if you need some people to speak to, I could probably provide those outside this, but
It's an issue of perception management as well. It might be a reasonably safe material, but if it's got the sort of nasties in it, people immediately push away from it. Whereas mineral wool seems to get a good report, but it's not necessarily the right product for every situation, particularly in systems that have cavities. It just seems there's a perception issue there as well.
Yeah. Okay, I'm conscious of time again. Thank you, audience, for bearing with us. There are some questions that we haven't got through, but as I said at the beginning, I will send those questions over to the panel, and that they've agreed to look through those and to respond appropriately. I am just going to have one final question, which I address to both you and Gary, and obviously very quickly. So, if there was one piece of advice you had to give somebody who is currently considering looking at a refurbishment, a cladding on a potential block, what would it be? So, Gary.
Simply do your homework. Don't go into it blind. Look at everything and take the time to get the understanding. Bring in the right kinds of advisors and involve the people who are likely to be doing the work and supervising the work. And don't just take a flyer on, this is how we always do it. Understand the block that you're working on and the product you're going to apply to it.
Brilliant, thank you. David?
Well as that, I'd probably say control. You're the client. You have control. You can control who you would like to install the product. You will have control of which product you would like. So if you've done your homework and you're confident and you get the right advice, you are the client, you have control. Design and build is not meant to be you don't have control. You have control. You're the client.
Excellent, brilliant. And on that hopefully positive note, I'm going to conclude today's session. Again, we will get back to you with the questions. You will be able to receive a copy of both the presentations. They'll be available on our website, or we can email them directly to you if you wish. So a big thank you to you, the audience, for being there this afternoon, and a very big thank you, round of applause from me to Gary and David for 2 excellent presentations and for taking the time to be with us this afternoon. Look out for the next round of Fusion 21 webinars, and again, all it leaves to me is to thank you all again and to wish you all a good afternoon, and as ever, stay safe. Thanks a lot and goodbye.
Bye.